I hope everybody doing good. So today we plan to see uh, how to use Spark into Azure Fabric services. So in the previous sessions, we just discussed about what is Azure Fabric services and what are the features it has, and then some exercise about Azure Lakehouse. So how to use the Lakehouse, how to create the Lakehouse, how to query the data in the Lakehouse, using a Lakehouse, how to create the a semantic model, using some semantic model from Lakehouse, how to create the Power BI report. So these are all the concepts we already completed in my previous session. So if you want, you can watch my previous session to understand these concepts. So today's session we plan to see mainly Azure, Spark, Apache Spark in Microsoft Fabric. Let's go to the session. So I will try to cover some exercises also in the single session. Let's see how the based on the time we will decide how it will go. Let's see. Let's go to the topic. I'm going here. Yeah. So the introduction perspective, yeah, I think people who already have the experience with Apache Spark, uh, people who already worked with Azure Databricks or Azure Synapse Analytics with the Spark pool. So the same concept and all the technology whatever we used in ADV or Azure Synapse Analytics, we can use the same concept in Microsoft Fabric as well. If the people not familiar with Apache Spark, I request you guys to go through the Apache Spark material first, and then come to this video. That case, you will easily catch up what is going on. So the mainly like in the data perspective, majority of the places we used to use we always using Azure Spark contexts. So mainly we will use data frame, RTT, and data set concepts nowadays. So no very rare places we are using, and many of the majority of the places we are using as data frame concept. Either is a Spark data frame or Pandas data frame. So here in the PySpark, Python Spark. Moreover, in this document, we will cover Python Spark and a little bit of the Spark SQL as well. Let's go to this. So when it's coming to the Apache Spark, it's core technologies and supporting large scale data analytics. So if you want to deal with very big data, then you can go with Azure Apache Spark. Apache Spark. Otherwise, you can use normal table concept or semantic concepts in your data lake itself. If you want to deal with very big data and you need to perform huge volume of transformation logics, and if you want to implement the very big business logics, then you should go with Apache Spark. So also so in this session mostly like we will cover how to configure the Apache Spark in Microsoft Fabric Workspace, and then like identity suitable scenario for Spark notebook and the Spark jobs. So like where we need to use a notebook and what kind of Spark job we need to create, and other than that how to use a data frame to analyze the data, transform the data, and then how to use Spark SQL to analyze the data, and even using Spark SQL we can create the tables and views. And other than that, there is a feature is available. I think the people already worked with Azure Databricks. You may know we can see in Databricks itself kind of basic level reporting. So same visualization is available in Azure Microsoft Fabric's notebook as well. Okay. So if before starting this model, you should be more. You should Microsoft Fabric into this core concept. Okay. So this is whatever we already the previous session we covered lake house, right? So they are saying this is a prerequisite, because first you need to understand what is Microsoft Fabric, and then how to improve, how to implement the lakehouse in the Microsoft Fabric. These two concepts you should know, then only you will understand Spark concept of because of using these two, mainly we are using lakehouse for data storage purpose in Spark Apache. So whatever we stored in the lakehouse, we were going to read from read using Apache Spark, and then on top of that we will build some transformation, and again transform data we will write back into lakehouse. So you should know the you should know how to create the lakehouse. Then if you are familiar with that, then this is good to go. So already completed these studies, that's what it's showing everything's tick mark. So let me go with this introduction first. Okay, so Apache Spark is one of the, like, open source parallel processing framework for large scale data processing and analytics. So Spark, yeah, Spark has become popular in big data processing scenarios and is available in multiple platform implementations, including Azure HT Insight, Azure Databricks, Azure Synapse Analytics, and Microsoft Fabrics. So this means, like, what they are trying to say is, like, the Apache Spark is a open source platform processing framework. It's supporting for very big, large scale data processing and analytics. So it's become more familiar when you, in the olden days we can see, like, there are Hadoop big data as concept came. So those days Spark, Spark engine was a parallel processing engine. So it supported a very big scale, big data, big data analysis. And then the same Spark, the same Spark is now supporting in Java, and even Azure HT Insight, Azure Databricks, and Azure Synapse Analytics, and Microsoft Fabrics. So this we are going to see only Microsoft Fabric level how to use a Spark. Okay, prepare to use Apache Spark. So yeah, the Apache Spark is distributed data processing framework. So they, again, the same story. It's kind of, data processing parallel, distributed data processing, and supporting large scale, and other than that, it's supporting parallel processing as well. So to do that, we need to do some settings. Uh, Spark can run code written in a wide range of languages, including Java, Scala, Spark, Spark SQL, PySpark. Most data engineering and analytics workloads are accomplished by using a combination of PySpark and Spark SQL. Yeah. So the Spark engine, or Spark compute, or Spark cluster will support these all the languages. Uh, it's kind of initially, including it's supporting Java, Scala, Spark R, Spark SQL, and Spark and PySpark. So most of the concept, like, people who are working in Azure Databricks, either they will use Azure, Scala concept, and nowadays majority of the people using PySpark or Python SQL, PySpark or Python SQL. I mean, like, PySpark SQL, Spark SQL. So to do that, we need to set up some Spark settings. So Spark setting is nothing but we need to create the cluster first. On top of the cluster, we need to mention some of the main properties, how much the compute we need, and what is the cluster capacity and memory, everything. So if you go here, we can set up like this. So we need to create the data engineering, under data engineering and data science. We need to create the Spark compute. The Spark compute, we need to mention the memory, uh, node family, and then runtime version. So this is specifying your Spark versions. So what is the latest version based on the, if you want to support your all your latest Python concept, then you need to go with the latest version of your runtime version. And then you need to mention the it's high concurrency or standard versions. And also there is option automatically track machine learning experiment and models. So this means, like, if you want to build your, if you will build the machine learning concept, then automatically it will create the machine learning model. And if any machine learning model is experiment is happening, then it will detect, and it will create the models. That's what the settings we need to specify. So this mainly the specific configuration node family first. The type of virtual machine used to Spark cluster node, in most cases memory optimized node provide optimal performance. Uh, Optimal performance. So that means like your node family should be memory optimized. So that case it will be support high performance, and it will be more faster. And then runtime version, as I told, as I highlighted previously, it should be the latest version. That case your latest concept with Python will work. We need to specify the Spark cluster version. And then Spark properties. Uh, so there are, if you see this document, you can see the what are the Spark properties we have. Um, those are the properties we can specify: app name, course, maximum result size, driver memory, whatever you want, and driver memory overhead. So we like kind of, it's kind of Spark Apache Spark admin works. So you need to make sure whatever you need the configuration in the on top of the cluster, then you can set up those. Also, like in Python, sorry, in the cluster we can install whatever the libraries we need. So based on the library, it will your code will support, and you can write the code on top of the uh, first you need to import the libraries, then only your code or your functions or default functions or whatever the concept you are writing, that will work. So there's a then like mostly the cluster based on library files, it will support, it will run, like it will execute your codes. Okay, next concept is run Spark code. So mainly, like, there is a concept called notebook. So notebook is nothing but it's a combination of multiple cells. You can able to run individual cells separately, the other, as well as you can run your all the cells like a sequence order as well. So you need to create the notebook. On top of the notebook, in the notebook level, you need to mention your code. Either you can mention as a SQL or a Python notebook. So if you specify as a Python notebook, then your code should be Python. If you want to run your SQL notebook, you need to use some kind of magic commands. Uh, so if the person have the experience with Databricks, they know what is magic command. Otherwise, the example, like in the when we go for practical session, I will explore. I will explain it very clearly on that. So again, if you want to use Spark and just to transform data about automated process, you can define Spark job to run. Yeah, it is simple. Like once you develop the notebook, if you want to schedule that notebook to run particular timing or particular days or page by page process, you need to build your Spark job. So that will then you can import that your notebook which you need to be, which is need to be run. Then it will run based on your Spark job schedule timing. Okay, so that's what. Uh, like here, what they are trying to say, you need to create the notebook. On top of the notebook, you need to create the Spark job. So the job will invoke your notebook. And it will schedule as per the Spark job schedule timing. Okay, work with data. Yeah. So once you create the notebook, then you can write your data frame. So data frame is nothing but it's a SQL concept, like Spark concept, Spark concept. Uh, like natively the Spark support RDD and data frame. Uh, Natively, the Spark uses data structure called resilient distributor dataset RDD. But while you can write your code that work directly with RDD, the most commonly used data structure for working with the structured data in Spark is data frame, which is provided as part of the Spark SQL library. Data frame and data data frame in Spark are similar to those in ubiquitous pandas Python library, but optimized to work Spark distributed processing environment. Yeah. So what they're trying to say here, In Spark, we can use RDD as well as data frame. If you are dealing with non-structured data or semi-structured data, you can use the RDD. If you are going to deal with structured data, then you can go with data frame. Even if you are dealing with non-structured data or semi-structured data, you can use RDD and change as a structured data. Then later you can use as data frame. So that's what they are trying to see, trying to explain here, try to mention here. And then it's part of Spark SQL library. So you need to import the Spark SQL library before writing your data frame. And it's similar like Pandas data frame, but in Spark data frame, it's supported distributed processing, so it is optimized one. Yeah, loading data into data frame. Yeah, so once you create when you're creating the data frame, you can directly load the data into your data frame, and then you can display that. And even on top of that, you can build your business logic. Like you can implement your business logic and build your transformation, and then write using data frame, you can write directly to the lake house as well. So that's what they are trying to say. uh, and there is an inferring schema. Inferring schema is nothing but when you read the file, if the file have the headers, then you can mention as a header true. Then the data frame automatically create a header as a file, whatever file, like in the file level, whatever the field we have, that will create as a header for data frame as well. Data frame as well. Yeah. So here this example code they given here. What they are doing, they are just reading the data from file location under data folder product or CSV, and that file format is CSV and the header true. So that means like this file have the header column. So it will consider as a first column as first row as a header, then second row onwards it will consider the data. So they are just displaying just to limit just 10 rows. So when you go for the practical session, I can show you clearly, so you will understand what is happening here. And then yeah, the same code, this is Python, they explained with Scala. This is a magic command. I think just 5 to 10 minutes before I told you what is magic command. So your notebook is type of Python notebook, but if you want to run Spark Scala notebook, then you need to mention as a Scala PySpark. Okay. Yeah. So specifying an explicit schema. So for example, your file does not have the header. First row is a header. First row is as a data. There is no header in your file. You need to specify explicitly the schema for that. That means like explicit schema in the sense you are going to specify the column name for that. For example, you have multiple columns in your file based on the sum delimiter. I think this example 77 is the first column, and then mountain 100 silver is the second column. 38 yeah, mountain 10 100 silver 38 is the second column, and then comma mountain pike is the third column, and then 33998 is the fourth column. So it doesn't have this. If this CSV file doesn't have any headers. So when you read the file, you cannot read as a header true. So you need to just read the data, and then you need to specify the column name for those 1 2 3 4 field, and then you need to specify the data type as well for those four attribute. So for that, we can create struct type to specify the schema for the file. So what we are doing, we just importing the library files, and then we are specifying the schema for that: product ID, product name, category, and last price as a product schema. That means we are specifying the schema here. And then when you read that file, we will specify the schema as a product schema. So this means like the first column goes to product ID, second column go to product name, and then third column will be category and list price. That's what we plan to specify here. This is another way to read the data with uh, with like explicit schema, uh, whichever if the file does not have the header, then you can use this way you can use it. Okay. And in the data frame level, we can do the filter, or you can do the select, and you can do the grouping, and whatever we can able to do, whatever we can do in SQL Server, kind of group by, order by. So all those things we can able to do in we can do in data frame. So that's what they are mentioning here. Yeah, pretty much. Yeah, this and then saving data frame, it's nothing but like when you using data frame, you can write the data to your lake house. This is a file location as a parquet file location. uh, so when we yeah, in the last session when we discuss about Azure data lake house, so we talk about writing the data to lake house. So using notebook we can write the data. So this is the way we can write the data to lake house, or we can write as a table also. This is we are writing as a circuit file as a no, into the circuit file format into the lakehouse. And then partitioning the output. So I think this is a kind of partition will be optimized optimization concept. So when you if you are dealing with very big data, so you need to go with the proper partition. That case your file will be uh, very fast when you deal with the business logic, or when you even if you are going to if you will read this file or this table again to your notebook to perform any kind of transformation logic, the reading will be very faster when you create the partition. So partition can be single column specific, or even combination of multiple column also. That's what they are maintaining, they mention here. Yeah, so same things. So we are loading the data with the partition specific. Then it will go on to store, and the partition the backend the partition will create. So each and every category will separate, it will be separate partition will available. So whatever you are writing as a road bike, so this category will become road bike as a partition, then the data will get stored in the backend. Yeah, so what they're trying to say in this, so using so notebook, you can write your data frame. Using data frame, you can read, and you can do whatever manipulation, and even you can perform ELT or ETL process, and then write back into to your lakehouse. Similar concept they are trying to explain here. Whatever we performed in data frame, we can able to do this. We can do using Spark SQL as well. That's what they are explaining. So if you want to do Spark SQL, once you read the data to your data frame, then you need to create the temp table. Once you create the temp table, in the next level of the notebook cells, you can use this as a table, and you can perform whatever you want as part of business logic. You can write, and then finally you can write the data data frame. Again, you can convert your view to data frame and write it to table as well. Yeah, so here what they're yeah, this is what like instead of creating data frame, if you mention PyTF spark.sql, then inside that syntax you can write your own SQL queries. Even you can join the tables, and whatever you will perform SQL concept you can perform here, and then write as a data frame. Then you can consider the data frame and going for next level of your notebook cells or notebook or cells. Yeah, so that's what in the notebook level you can use Spark data frame or Spark SQL. And if you like both are same. No, performance perspective, both are same. Some people will more comfortable with data frame concepts. Some people will uh, more comfortable with SQLs, so they can write their own business logic and they can implement with any concepts. And the next one is visualize data in Spark Notebook. Yeah, that's what in the beginning I told, like I highlighted, like we can able to visualize the data using some basic SQL, no basic graphical functionality available in notebook level. So once you, by default, if you see the data, by default if you select the table, then you can see the table output. You can select as chart, then based on your output it will show the basic level reporting. So this is very basic level. If you want to measure, like high level of reporting, then you need to build your Power BI report. So to do that, you need to implement the Python matplot library, pyplot. Then only you can build the graphical design as well. So like matplot library in Python support for multiple uh, visualization. You can implement that, you can import that, and then you can build the report like this kind of bar chart. No, this is we are not sure, like this is a a more efficient way, because when you deal with very big data, you cannot have comfortable reports. It's very basic level report. You need to go with Power BI report or some report or some other reporting tool to build your proper report. But this feature also available. Very basic level report feature is also available in notebook. That's what they are trying to highlight here. Okay, let's go to the exercise now. Okay, I'm just launching the. Okay, create the workspace. I think in the previous session I covered this concept, how to create the workspace and then how to create the lakehouse. So I'm going to reuse the existing uh, workspace and lakehouse, so to implement the Spark concept here. Okay, so first upload the files. So I have already downloaded these two files. If you want, you can go with this same location and download it, and you can do your own practice. So, and then yeah, so once you uploaded this file, you can see these three files, CSV files, the lakehouse, and then I'm going to create notebook. In the notebook level, I'm going to uh, I will plan to write. No, we will plan to we will see some exercise. Let's go here. Yeah, so previously I created demo lake 2024 lakehouse in the previous session. So we had the file called sales, and now we have yeah, there are two files. Previously the last session we had a sales.csv. So for today's sessions, I already uploaded these three files into the lakehouse. I'm going to use this and build the notebook. I mean, like I will build the I will create the notebook and use this file to perform the transformations, or read and Spark concept. We will see the data frame and the Spark SQL concept. Let's go to open new book, new notebook. I'm just typing demo notebook 2024. Okay, yeah, so by default you can see it is giving the language Spark, Spark Scala, Spark SQL, Spark R. So if you want to write Python codes, then you can go with the Spark Python, PySpark Python. If you want to write Spark Scala code, then you can go with the Scala, and we are going to write only SQL, Spark SQL. Okay, if you familiar with the Spark R, then you can go with R. So I'm going to I plan to go with the PySpark. let's go here. So it's default messages. Okay, so we are going to load the data into data frame using these files. uh, for that there is a default query already they given, so I'm just going to copy this and paste it there. So here what we are doing now, environment. Yeah, I'm not no, I'm not showing any cluster configuration because uh, we are using default cluster. We don't have the permission to create any cluster in this workspace because this is a trial workspace. So they given minimum workspace, no minimum necessary, no minimum capacity of cluster. So the cluster runtime engine is 1.2 and compute medium 1 to 1 nodes they have. So it is limited for no training purpose. So if you have a license version, then you have the opportunity to build your own cluster and specify the configuration as well. So let's go this and yeah. So what we are doing, what we are going to do, this is the data frame, and then we are going to read the data frame, and we are going to read the file CSV file. This is a 2019 CSV file from this location, and then getter is true. Then we are going to display the data. Let's run this. So it's running. Yeah. So we can see here this is a table from that file. Like these are all the column we have, but I don't think the file is not proper. See here, we have mentioned header is true, but if you see here, the first row itself data. So I don't think this file have the headers. Maybe let's go with another file. Let's see it's have that headers or not. No, no file, no file. All the file does not have any headers. So that's what it's showing first rows here, like this. And then if you see the chart, yeah, chart also coming like this. Okay. Okay. So I'm going to add another cell down, and then see. Yeah, so that's what they are expecting here as well. So the first column will be the index. It's just kind of auto identity columns 1 2 3 like this it's showing, and then second column without header. So that is what the data without header, it's considering first row as a header, and even the file does not have a proper header. Data showing as a header and displaying the data. See, this are the S043701. This also one of the data. This row also data rows, but considering first row as a header, but it's not the proper header. Okay, but for this we need to specify the header as well. So let's see in the next cell we can see that with the header. Yeah. So in this example, so this this code they are highlighting. So here we mentioned as header is true. That's why the first row is header is coming. In the next set and the next cell, we are we are providing header as false. So that case it will give us default columns. So column 1, column 2, column 3, column 3, column 4, column 5. So this is what default column names it's coming. Okay. So next, go to the next cell. Yeah, so in this example, what we are going to do, we are going to specify explicitly the schema structure for the file. Okay, so we are creating the structure order schema as a schema type, structure type, and specifying the attribute name and then data types. Then we are ready. Let's see that how the data will be look like. So we are creating explicitly schema, and then we are mentioning the column names, and then we are reading the file. So when you display the file, you can see sales order, sales number, sales order, sales line number, order date, customer name. So these all the attributes are coming with the proper whatever we mentioned in the schema. That's another cell. So we specified only one file. So it is showing only one file. So if we will specify dot star, then whatever the CSV file available as part of this folder, everything will read. That's what they are highlighting here. Something's rare. Most probably this is space error. Yeah. So what is doing this? It will read entire all the files from this folder. So whatever the file ending with the .csv, all the files will read and display here. That's what they are highlighting here. Yeah, so here filter the data. So whatever customer name and email ID, we are getting the data frame that particular columns and putting the counts. So just they just explain, they just trying to mention here how many email IDs and how many customers name we have. So if you see 3721224, so as part of all the files, these are all the data we have, and then these many customers and these many, yeah, yeah, customers start customers distinct count, yeah. So distinct count this much, and this is the overall count, and then we are displaying the customer and the email. So we can perform any aggregation, like kind of group by, and then item wise, how much the quantity. So what we are doing here, this query we are going to select item and quantity, group by item number, item sum of the items. Let's go here. This is very they have mentioned a very basic level kind of all calculations. Yeah, these are all the basic level operations which we will perform in most of the data analysis projects. Let's go to this. Let's go to Yeah, they are doing some of the transformation as well here. uh, if you see this, they are they are transform df with the year, then transfer first name, custom name, get items. So based on the multiple, they are building multiple data frame. Like they are using some like one by one same data frame and building multiple kind of they are building different columns. So if you are familiar with already Spark data frame concept, you can implement all your concept here. It will support as it is Databricks or Hadoop or even Azure Synapse Analytics level. Whatever we are, whatever we can able to do, whatever we can do, same things we can do here as well. So yeah, all the transformations we can able to do, and then finally we are writing this data frame as a circuit file in the order folder. Let's show this. So let's go here. Yeah, you can see there is a transformed folder. So order, if you see here, yeah. So the file saved as a circuit file here once you write. So this is the one of the way to insert the data or to tell Lakehouse. And so using data frame, we can write the data. Okay. Yeah, that's what I shown, and then we can create partition, order date, no partition specific data. When you write the data into a table, you can create the partition and write the data as well. This is like house. Yeah. So now another concept we covered, as part of the theoretical explanation, there is a data frame concept as well as Spark SQL. So whatever we performed as a data frame, we can do the same thing as a table as well. So let me write this. So what we are going to do now, so we are going to use, so we are writing as a table, and then later you can able to see the data in the table side as well. So that's what, using the notebook, you can able to you can write the data as a table, or you can write the data as a circuit file. You can read the table, or you can uh, read the file as well. Refresh. See, sales order is another table got created. Yeah, whatever we implemented the logic in data frame, we can do the same with Spark SQL as well. That's the explanation they given here. So I think if you want, you can we can see some more example using Spark SQL. So what we are doing here, we are creating the data frame and using Spark SQL and reading the data from Lakehouse. I think demo Lakehouse. We have to mention. Let's see what is the error. Yeah. So it should be demo underscore Lakehouse underscore 2024. Let's copy the path. sales order tables. So it is giving the API plus path. So we can read as a API plus path, and then we can use this. Okay. Yeah. So you can from sales order. I don't think it will work because we need to set up the API plus. So in the next session, I will try to cover API plus read as well. Let's see how this is working. Yeah. So this is a magic command. If you want to know, it is a Spark SQL Python notebook. Then Python notebook level, if you want to run SQL queries, then you can use percentage SQL. So that case you can able to write your SQL query. So we are just doing we are reading the years of from ROT. We are taking the years and then sum of unit price and quantity plus tax as a gross revenue. Group by and order by. So whatever we are writing the SQL query, we can write and do the things. And if you want, you can create the data frame and put this SQL query as a Spark.SQL query. Then you can use the data frame for your analysis purpose. Okay. So for chat, let's go with this. Select star from sales order, and then we will. Yeah. Let's go to the chat. Yes, individual numbers item name. It is showing us average sales orders. Let's customize the chat. Let's go with the pie chart. Let's see how that looks like. Let's see. Yeah. So these are all default chat supporting. So you can change the chart type and then whatever kind of like computer set you can change, and you can see kind of basic level report detail. Yeah. Okay. Yeah. And then there is a library called matplot library. So this is supporting a lot of graphical chat. So you can implement, you can use that as well in your cell, and then you can so we are importing matplot library, and then we are building our own for pivot and pivot chart and customize bar chart, and then we are showing as a chart. So let's run this code. You will understand what is happening. So similar like this, we have multiple libraries. We can implement the libraries to support with visuals. So you can write that tf.sale. Where is tf.sale? Where is tf.sale? I think we in the top we never created tf.sale, right? That is what this error. Let's go and see any. Let's use tf. If these columns are part of data frame, then it will show. Otherwise, it won't show. We need to fix that. So it is not part of order here is not part of the data frame. So now what they're trying to say here, like using MATLAB and even multiple libraries, we have to support chat. So you can implement that. You can import that libraries, and you can build your reports on top of that. But before that, you need to build your data frame, which should have all the columns, whatever the necessary column. Then you can pass the data frame to here, and then build your charts. Okay. Yeah. Similar like MATLAB, matplot library, zbone library is there, so that also supporting charts. And then if you want, you can use that. And then yeah, similar like this, we have a lot of libraries, so you can use those things and build your own reports. Yeah, this is what, like we can use Spark in Azure Fabric and build your data frame, data breaks, data frame, and Spark SQL. Implement your you can implement your business logic and write back to lakehouse. So you can read the data from lakehouse and build your. So whatever you have, you can able to do in Azure data lake storage and Azure Databricks. Everything you can do in Apache Spark with Azure, Microsoft Azure Fabric services. This is what we planned. So in the next session, I will try to cover how to create the data lake with data lake table in Microsoft Fabric. How to build the data lake table. So that is one of the bigger concept, data lake concept, like kind of a data table. That is one of the optimized way of maintaining the tables, and then it's supporting a lot of functionality. It's supporting version maintenance as well. In the next session, we will see the data lake concepts. So I hope this is everybody understand this. If you have any questions or if you have any doubt, you can feel free to reach out me via my YouTube videos and comments. I will definitely respond back. Thank you everyone. Have a great day. Bye bye.